Hello everyone. In the last lesson, we learned the features of asphalt. In this lesson, let us now examine how it dons various vests, transforming into a key waterproofing material and a primary component of pavements. First, let's look at the three basic products of asphalt. Works out all time. It is the product of thinner and asphalt, usually brushed on the bottom layer of waterproofing project at room temperature, and plays the role of base treatment. Asphalt binder. It is made of asphalt mixed with mineral filler. It functions as a universal adhesive, primarily used for bonding asphalt felt, coating surface layers or sealing cracks and leaks. And this is a sealing compound made from petroleum asphalt as the base material, with the addition of modifying agents and fillers, specifically responsible for waterproofing gaps in roofs and walls. Asphalt waterproofing membranes have also undergone an evolution from ordinary to high performance. Ordinary petroleum asphalt membranes, made by saturating and coating base paper or fiber felt with asphalt, including reinforced and unreinforced grades. Polymer modified asphalt membranes. To address the drawbacks of conventional membranes, namely poor temperature sensitivity and susceptibility to fracture, synthetic polymers have been incorporated, significantly enhancing their elongation and stability. Self-adhesive membranes. The lower surface is compounded with butyl rubber and other adhesive materials with its own back adhesive, which makes the construction more convenient. There are two kinds of asphalt waterproof coatings: asphalt-based waterproof coatings and polymer-modified asphalt waterproof coatings. Asphalt-based waterproof coatings refer to waterproof coatings with asphalt as film-forming substances. There are two types: solvent-based and water emulsion-based. Solvent-based asphalt waterproof coating is composed of asphalt, solvent, modified materials, and auxiliary materials. Water emulsion-based asphalt waterproof coating is made by emulsifying petroleum asphalt, water, emulsifier, and auxiliary materials. Common types include emulsified asphalt waterproof coating, lime mortar emulsified asphalt waterproof coating, etc. It has low price, simple production process, and convenient use. Polymer modified asphalt waterproof coating refers to water emulsion or solvent-based waterproof coating, which is made by asphalt as base material and modified by synthetic polymer. Compared with asphalt-based waterproof coatings, it has great improvement in flexibility, crack resistance, tensile strength, high and low temperature resistance, and service life. Let's look at the focus of this lesson: asphalt mixture. This is the most widely used material we usually see. Pavement is actually a kind of asphalt mixture, which is made of mineral materials, crushed stone, sand, and asphalt. In this system, the mineral material acts as a skeleton support, while the asphalt and fillers are responsible for cementing and filling. It requires no expansion joints, is comfortable to ride, and quick to build, making it the first choice for high-grade highways. The formula of the mixture is very particular. Different types of asphalt materials have different technical properties which are suitable for different grades and types of pavements. Thicker asphalt should be used for heavy traffic in relatively hot climate zones. There are also coarse aggregates composed of crushed stone, fine aggregates composed of sand or stone chips, and fillers composed of stone powder, which together determine the quality of pavement. The most important part of the mixture lies in its composition structure. In the previous lesson, we learned that petroleum asphalt has three composition structures, namely sol structure, gel structure, and sol-gel structure. The asphalt mixture also has three kinds of composition structures, namely suspended dense structure, skeleton void structure, and skeleton dense structure. Let's start to learn them one by one. 1. Suspended dense structure. This structure has more fine aggregates than the coarse. The coarse aggregates look like they are suspended in the fine aggregates. It has the advantages of high density, good strength, and difficulty in segregation, and is convenient for construction. But the disadvantage is that it lacks skeleton support and has poor stability. This is the commonly used structure of asphalt concrete in China. 2. Skeleton void structure. In contrast to the former, it has more coarse aggregates than the fine. The coarse aggregates are tightly embedded and squeezed into each other to form a skeleton. Although this structure has excellent thermal stability and is less affected by temperature, its durability has become its shortcomings because of large voids and insufficient adhesion. 3. Skeleton dense structure. It is an ideal structure that combines the advantages of the first two. It has enough coarse aggregates to form the skeleton and enough fine aggregates to fill the voids. It has high strength and good stability, but because coarse and fine aggregates are easily separated during construction, it has very high technical requirements and its application is not widely enough at present. Then let's look at the technical properties of asphalt mixtures. 1. High temperature stability. In summer, the road surface may reach above 80 degrees Celsius under the scorching sun and wheels. The road is prone to bulging or waves. In order to resist deformation, we can increase friction by reducing the amount of asphalt, improving the adhesion of asphalt, or choosing angular mineral materials. 2. Low temperature crack resistance. In the cold areas of the north, we should prevent asphalt from freezing and cracking. At this time, low adhesion asphalt or rubber modified asphalt can be selected, and the dosage can be appropriately increased to enhance its flexibility. 3. Durability. The porosity and asphalt content of the mixture are important influencing factors. The key lies in controlling the porosity and asphalt content. Excessive voids accelerate aging. Insufficient asphalt results in thin films that are prone to damage. 4. Skid resistance. Asphalt pavement is mainly used by vehicles, so it should have certain skid resistance. Skid resistance mainly depends on the roughness of the asphalt mixture, the gradation composition, the amount of asphalt, and the properties of the microsurface of the mineral aggregates. Do you want to make the road more anti-skidding? The key lies in these points. A well-designed gradation, a rough surface texture combined with aggregates possessing favorable microsurface characteristics, and a sufficient amount of asphalt. A pavement formulated in this manner will naturally exhibit excellent skid resistance. 5. Workability. Workability means that the asphalt mixture is easy to mix. Paving and rolling construction, it is mainly influenced by aggregate grading and asphalt dosage. With the continuous grading aggregate, the asphalt mixture is easy to mix evenly and does not produce segregation. If there is insufficient fine aggregate, the asphalt layer is not easily uniformly wrapped on the surface of coarse particles. If there is excessive fine aggregate, it is difficult to mix. If there is insufficient asphalt, the mixture is easy to loosen and difficult to compact. If the amount of asphalt is excessive, the mixture is easy to bond into blocks and difficult to pave in. The design task of mix ratio is to determine the proportional relationship between coarse aggregates, fine aggregates, fillers, and asphalt, so that various indexes of the produced asphalt mixture can meet the engineering requirements. It mainly includes two kinds of designs. The first is the composition design of mineral mixture, which includes coarse aggregates, fine aggregates, and filler. The second is to determine the optimal dosage of asphalt. So, how to determine the specific ratio? In China, the most widely used is this kind of continuous gradation with easy construction and good uniformity. Please look at this picture. What we have to do is to adjust the proportions of various materials so that the final synthesized gradation curve accurately falls within the shadow area in the picture. We can understand it in this way. Suppose we initially try the plan of 30% coarse aggregates, 40% fine aggregates, and 30% fillers. If the calculated curve is just within the shaded range, it means that the gradation is reasonable and usable. However, if the curve crosses the line, for example, excessive coarse aggregates cause the curve to go out of this range, then we have to adjust flexibly through decreasing the proportion of coarse aggregates a little appropriately and increasing the content of fine aggregates and fillers until the curve returns to the shaded area. In order to determine the optimal amount of asphalt, we need to perform a series of Marshall tests. Observe the changing process of various performance indexes of the mixture under different asphalt dosage. Please take a look at these coordinate diagrams. The upper left corner is the stability. We need to see how it fluctuates with the dosage. The second is the flow value, which represents the fluidity change of the material. The third is density, i.e., observing when the compaction reaches its maximum level. Finally, there are porosity and saturation, which are directly related to the durability of the pavement. The logic of determining the dosage is very simple. That is, put it in the right place. For example, the specification requires that the stability must be above 6.0. So we will draw out the asphalt dosage range that meets the conditions. The flow value is required to be between 20 and 40. We also draw the corresponding range. Similarly, the range of porosity, such as 3% to 6%, and saturation should be marked one by one. Here comes the most critical step. Look at this comprehensive graph in the lower right corner. When we overlap the qualified ranges of all indicators, we will find an overlapping area. This overlapping zone is our safe zone. In this area, we usually choose the middle value or the amount corresponding to the point with the highest reference density. Through the two steps from blending mineral material to determining proportion, we have completed the mixing ratio design of asphalt mixture. Everyone, in this chapter we learned from the basic knowledge of petroleum asphalt to its all-round application in waterproofing engineering and road construction. I hope you can remember that whether it is waterproofing or road construction, reasonable proportion and structure selection are the keys to ensure the project quality. In the future, I hope everyone can accurately control these indicators in your respective positions and contribute professional strength to our infrastructure construction. That's the end of this chapter. Thank you for watching.